All right, so our next video here deals with just some more examples, and then we're going to look at the general form of all conics. But first, a quick example, one more of hyperbolas. Find the center, the vertices, and the foci for this hyperbola. X squared minus 9y squared plus 2x plus 36y minus 53 equals 0. Now, when it comes to an ellipse, the math will work out. We're not going to be able to determine whether it's a horizontal or vertical necessarily until we get to the end of the problem after doing all the completing the square and everything, and then we just change the order because with an ellipse, there's an addition sign in between the two fractions. So with an ellipse, we can change the order of the fractions and always make sure that the higher denominator, the bigger denominator, is first, and that tells us whether we're horizontal or vertical. With hyperbola, I don't have to worry about that. I can tell right away whether it's going to be a horizontal or a vertical hyperbola. I simply have to look at the squared terms. With x squared, there's a coefficient of a 1, and with the y squared, there is a coefficient of negative 9. Since the y squared is negative coefficient, that tells me immediately that this is a horizontal ellipse. X is going to come first because the minus sign is with the y squared. If it were the other way around, if x had the negative sign, then it would be in a hyperbola that opens vertically. But it's not, so we're good to go. A lot of the steps are going to be exactly the same if you watched, and hopefully you did, any of the other videos on circles and parabolas and ellipses. We're going to be completing the square again. I'm going to reorder everything. So, oops, I need the right marker. I need x squared, and then I'm going to go plus 2x, and then I'm going to leave a little space because I know I'm going to have to complete the square. Then I have minus 9y squared plus 36y. Now, I'm not going to leave space here. I'll leave that on the next step. Well, I'll go ahead and I'll leave space anyway. Why not? Equals, I'm going to add that 53 over to the other side because I want all variables on one side and anything that doesn't have a variable to be on the other. Now we go ahead and we complete the square. For the x, because it's just x squared, I can go ahead and complete the square right away with that. I simply take the 2x, divide it by 2 and square it. 2 divided by 2 is 1. 1 squared is 1, so I'm going to add 1 to complete the square, but I'm not allowed to add 1 just to the left side, so I have to add 1 over here with that 53. For the y, I can't just go ahead and complete the square right now because it's got a 9y squared there. While it is possible to do, 9 is a perfect square, we could work it through that way, but it's way easier to do it the way we did it on the last video as well, and so, or 2 videos ago, so I'm going to do it that way instead. So, I know x squared plus 2x plus 1, actually let's wait to factor that, let's just go ahead and rewrite that, x squared plus 2x plus 1. We could factor it now if we wanted to, but I want to do everything all at once. For the variable, for the y's, I need to factor out the 9. Now I also want to factor out the negative sign. So I'm going to put the negative 9 here. And when I factor that out, that's going to leave me with a positive y squared and then minus 4y. Here's where I'm going to leave space to complete that square. And over here, I'll wait to put these together, 53 plus 1. If you want to write that as 54, go for it. So now I have to complete the square for the y's. So I got y squared minus 4y. If I take that minus 4 and divide it by 2, that's negative 2, and negative 2 squared is positive 4. We're always adding. And so I'm going to put a plus 4 there. Now again, just like we did with ellipses a couple videos ago, I can't just go plus 4 here because I didn't really add 4. I added 4 in a parentheses, and that changes the value. So let's get rid of that plus 4. What I'm really adding, let's get rid of the plus sign as well. What I'm really adding, or in this case subtracting, because that negative 9 is out in front, that negative 9 is going to multiply that 4. So I didn't actually add anything. I didn't add 4. I actually subtracted 36. And so that's what I need to tack on over here. Whoops, instead of the... There we go. Instead of plus, I need to change that and make that minus 36. It's simply just making sure that you're paying attention to what you're doing and not just being a robot. You actually have to think. I've mentioned this so many times. Math is not about being a robot and just following a list of steps. If you do that, you're going to be a great robot. That is not what you need to be. You need to be a thinker. And so make sure you're thinking about what you're doing and not just becoming a robot and just doing the same thing over and over again. A lot of math is like that, but you got to think about the steps. So the next thing I'm going to do is I'm going to factor these two different variables. So x squared plus 2x plus 1, that factors into a nice x plus 1 quantity squared. The minus 9 is going to stay here, and in parentheses, that y squared minus 4y plus 4 factors down into a nice y minus 2 quantity squared. And then over here on this side, I've got 53 plus 1 is 54, minus 36 is 18. Once I've completed the square, then I just have to make this equation equal to 1, because that is how standard form looks. So to make this equation equal to 1, I have to divide everything by 18. So when I do that, I'll be left with the quantity x plus 1 squared divided by 18. When I divide by 18 for the next part, the 9 and the 18 will reduce. If they don't reduce, fine, but these reduce, and so the y minus 2 is going to be y minus 2 quantity squared, and the 9 and the 18 reduce down to a 2. And when I divide the other side by 18, 18 divided by 18 is 1. There's the equation for our hyperbola. Notice x is first, so that's what we expected. It all works out exactly the way that we thought. But we're not done. That's not what we were looking for. We're looking for the center, the vertices, the foci for this hyperbola. So first, the center. The center is very, very easy once you have the equation, because the equation always gives you the center. That's h and k. And so my center, I'm actually going to write out the word center, because we're going to have that c value from the last video and from ellipses, and I don't want it to look like that's what c is. So my center, h and k. H, we have x plus 1, so h is going to be negative 1, and then we have y minus 2, so k is going to be a positive 2, so our center is negative 1, comma 2. To get the other things, we need our a's and our b's, and we're going to have to figure out c. So I know from this formula that a squared is equal to 18. I know that b squared is equal to 2. So if I take their square roots, I don't need to worry about simplifying them. I don't care if you simplify these square roots or don't. Some teachers do and some teachers don't. I don't. And so go ahead and leave it as the square root of 18 for a and the square root of 2 for b. To get c, we have our formula. It is the Pythagorean theorem. C squared is equal to a squared plus b squared. And so if I plug those values in, c squared is going to end up equaling a squared. A squared is 18 and b squared is 2. And so that tells me that c squared is equal to 20, which tells me that c is equal to the square root of 20. Again, feel free to simplify that or not. I don't care. So once I have those values, I can figure out where my vertices are and where my foci are. To get my vertices, if you recall from the last video, and if you haven't watched it yet, why are you watching these out of order? Go watch them in order. It's just like a TV show, you're going to be confused. The vertices are going to be a distance of a away from the center. So since my center is at negative 1, 2, and it's a horizontal ellipse because it starts with x, y has the negative sign, it's the x that I'm going to be changing. I'm going to add and subtract the square root of 18 to my center, just to the x value. So my center will be negative 1 plus the square root of 18, my one vertex will be negative 1 plus the square root of 18, comma 2, and then the other vertice will be at negative 1 minus the square root of 18, comma 2. To get my foci, again, from the last video, we saw that the foci are a distance c away from the center, and so I just have to add and subtract that distance to my center. Again, we're only going to add it and subtract to the x values, so c was the square root of 20, so my foci are going to be negative 1 plus the square root of 20, comma 2, and then the other focus will be at negative 1 minus the square root of 20, comma 2. Once I get everything into standard form, finding all the things that I need is very, very easy. You just have to figure out the A's, the B's, and the C's and use them appropriately. B doesn't help you with anything except for getting C. And so there's our example of an hyperbola. And so then we have one more thing that we need to cover. We need to look at the general form of conic sections, and we'll do that on the next slide. So, heading over to the next slide, we have the general form of conic sections, and there it is, lots of letters. ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. That's our general form, so notice for conic sections, the general form always equals 0. That's not standard form for each individual, they all have different things, but general form for all conic sections, the equation equals 0. Now, one thing that we haven't seen yet is this term right here, this bxy term. That term would rotate your conic sections. So instead of being horizontal and vertical, they can be slanted. For an example, if we have a slanted ellipse, if this is our x and our y axis, it is possible for an ellipse to be slanted. we're not going to see that. So that bxy term, we're not going to deal with. We could, if we were actually in class, we would take some time and work through that. We are not going to here. So we don't have to worry about that bxy term at all. The other terms we've seen already, most of the problems that I've given you have been in general form. I just didn't call it general form. Regardless if we have that bxy term or not, I can look at the general form and determine exactly what type of conic section that I have. First, A and C, that's what it's all about. Those are the two unknowns that are really going to tell us what kind of conic section we have. The rest of the letters do not matter. Again, the B term, bxy term, tells us if we rotate it or not. So if that's not there, it's not rotated at all. Otherwise, the rest of the terms could or couldn't be there, but A and C will determine what type of conic section we have. So the first thing that could happen with A and C, if A and C are equal. If A and C are equal, then that could be like factored out, divided out, and that would just give us an x squared and a y squared. And that, if that happens, that's going to give us a circle every single time. Next, a parabola is pretty easy to determine. With a parabola, we only have one squared term, and so the way that we can set that up is we could say that if A times C equals 0, zero product property tells us that means either one of them is 0. So if I don't have an x squared term or if I don't have a y squared term, that's a parabola for sure. Next, if I look at A and C and if their product is positive, so if A and C have the same sign, if they're both positive or they're both negative, so if their product is greater than 0, that's going to give us an ellipse. Now, if A and C are equal, that gives us a circle, which tells us that a circle is simply just a special ellipse. Finally, if only one of A or C is negative, if their product is negative, because one of them is positive and one of them is negative, that will give us an hyperbola. And so if I have the general form, it's got to equal 0. As long as it equals 0 and everything else is there, all your like terms are connected, then this is what we can use to determine what type of conic section we have. So, you've seen examples for hyperbolas. I'm going to give you a few problems that deal with this as well. There's no real work to do unless it's not in general form. If it's not in general form, you just have to put it in general form, multiply things out, distribute, things like that, to get it into general form to determine what type of conic section you have. So your homework, your practice problems, page 675. We're going to do problems 11 through 17, the odds. 25 through 37, the odds. And then these last bunch, 57 through 62, that's all of them. You are just determining what type of conic section you have. So work on those problems. If you have questions, feel free to send me a remind. But that pretty much ends our conic section unit. And so the next videos that we will be looking at, we may go into polar coordinates. I'm not sure if I want to cover that or not. We may go into 3 dimensions. We may just jump into limits. So we'll see what is going to come next. But for now, work on those problems. And until next time, stay safe and stay healthy.